We're here with ResearchGate, and we're going to read Toward Location Aware, In-Body, Terahertz Nano Networks with Energy Harvesting. And we've been here before, looking at these images. Now we're going to read the abstract. Nanoscale wireless networks are expected to revolutionize a variety of domains, with significant advances conceivable in in-body healthcare. In healthcare, these nano networks will consist of energy harvesting nano devices passively flowing through the bloodstream, taking action at certain locations, and communicating results to a more powerful body area network, nodes. Assuming such a setup and electromagnetic nanocommunication in the terahertz frequencies, we propose a network architecture that can support fine-grained localization of energy harvesting in body nanonodes, as well as their two-way communication with the outside world. Two-way communication. That means that they're taking your physiological data and sending it out to the end user, and then they're also able to send back whatever they want,
they're replacing.
Yes, this is how they play with your cells, literally.
Right.
So they can send you whatever they want. They can change your heart rate, they can change your blood pressure, they can change the pressure in your arteries, they can change it all. And that's how much control and power they have. But yeah, so they can route data out and they can route it back in. Mm-hmm. So this is how they're making those changes on a cellular level, on the molecular level, because it's a two-way communication, not just one way. The main novelties of our proposal lie in the utilization of location-aware and wake-up radio-based wireless nanocommunication paradigms, as well as software-defined metamaterials to terahertz operating energy harvesting in-body nanonetworks. We argue that, on a high level, the proposed architecture can handle a large number of nanonodes while simultaneously dealing with the short range of terahertz in-body propagation and highly constrained nanonodes. I suggest everyone downloads and reads the full PDF file. But for now, we're going to go back to the abstract that we just read. And in the first sentence, it says, nanoscale wireless networks are expected to revolutionize a variety of domains, with significant advances conceivable in in-body healthcare. So now, we're going to Google in-body healthcare. And we're going to click on the images. Right here, there is this article called A Digital Nervous System Aiming Towards Personalized Internet of Things Healthcare. And we're going to be reading this in another episode. But as you can see, this is all for in-body healthcare. Now let's go over here. This is on the N3CAT website, which is a nano networking center. Scalable localization-enabled in-body terahertz nano network. Nanotechnology is paving the way toward nanoscale devices that are envisioned to enable several groundbreaking healthcare applications, such as molecular-level cancer detection, targeted drug delivery, and neurosurgeries. The nano devices are expected to flow through the human body, perform actions upon commands or at certain locations, and communicate the results to the outside world. There is, therefore, a need to enable two-way communication between the nano devices and the outside world, as well as their localization inside the body. These functionalities should be supported while simultaneously maintaining tiny form factors and low energy consumption profile of a potentially vast number of nano devices. In this scaled ITN project, we will utilize wireless signals and the terahertz frequencies for enabling both localization and communication capabilities for in-body nano devices. Localization will be enabled through terahertz backscattering, which is an unexplored paradigm that promises low energy and high precision localization at the nanoscale. The constrained communication range characteristic for in-body terahertz propagation will be mitigated through multi-hop communication. In such communication, only selected subset of nano devices and the multi-hop route will be awoken by utilizing wake-up radio-like signals. Selection of these nano devices will be based on their location estimates, as well as on their energy life cycle characterizations, if available through backscattering. This is again a novel paradigm that promises enabling low power, reliable, and scalable terahertz nanocommunication. The main outcome of the project is to develop a pioneering prototype of a terahertz nano network with both localization and two-way communication capabilities. Now back to this image. Your nano nodes wake up based on software-defined networking. Some of the nano nodes passively flowing in the bloodstream and energy harvesting entities to be localized for things like targeted drug delivery.